Students, all of you are welcome in the class 9th physics. Last class we had discussed about the measurements, okay, non-standard units of measurement. We are continuing that topic, okay. Last we had studied about cubit, handspan, fathom and pace. Now, difficulties with this non-standard measurement systems. What are the difficulties? Okay, these difficulty naturally arising in measuring distances. Suppose a teacher asks about the length of your desk. You can easily find the length in units of a handspan or thread length. However, if he asks you to measure the distance between the school and your home, between the sun and the earth, then you will face difficulties. You cannot measure this distance by using your handspan, gilli danda, thread length, etc. Okay, this quantity requires a standard scale of measurement. Mainly, the definitions, okay, measurement. So it is the process of assigning a number of attribute according to the rule or set of rules. Okay, means to express the magnitude of a physical quantity we should know two things: the unit in which the quantity is measured, mainly. Second, to express any physical quantity completely, we need a numerical value and the unit. The physical quantity, we can say magnitude of physical quantity is equal to numerical value of physical quantity into size of its unit. That is physical quantity, NU, fundamental units and derived units. Okay, but before this one, you should know the characteristics of a standard unit. It should be convenient size, it should be well defined, it should be easily reproducible and cannot change with time and place, can be easily available and cannot be changed with physical conditions. You should remember these characteristics of a standard unit. Okay, now fundamental and derived units. So fundamental units. Units of fundamental, we can say the units of measurement of length, mass and time are independent of each other, not definable in terms of other quantities, and units of all other physical quantities which can be obtained from them. The three basic units are called fundamental or basic units. The unit of measurement of all other physical quantities which can be expressed in terms of fundamental, that is mass, length and time. What are fundamental units? That we can say mass, length and time, which are known as are called derived units. Units obtained from fundamental units. Example, we can take unit of speed, meter per second. So what is the formula for speed? Speed equal to distance upon time. Unit of speed, unit of distance upon unit of time. So the unit of speed can be expressed in fundamental unit of length and time, that is meter per second. See this one. Speed equal to distance upon time, unit of speed, unit of distance upon unit of time. Systems of units: CGS, FPS, MKS and international system of units. So all system of units, we can say different units were assigned for mass and length in different countries. CGS, we can say basic unit for length, mass and time. In this system are centimeter, gram and second respectively. FPS, basic unit for length, mass and time. In this system are foot, pound and second respectively. MKS, base unit in the system are meter, kilogram and second. International system based on 7 base units. At present, internationally accepted system. Okay, MKS, we had studied its use meter as the unit of length, kilogram is the unit of mass and second as the unit of time. When MKS system is extended to electricity, the current as fundamental quantity ampere is taken as unit. Okay, SI basic quantities and units. Clear? Mainly these are the some system of units. You should remember CGS, FPS and MKS. SI base quantities and units: length, meter, mass, kilogram, time, second, electric current, ampere, thermodynamic temperature, Kelvin, amount of substance, mole, luminous intensity, candela. And derived units, the units of different physical quantities that can be derived from 7 basic fundamental units. These are the derived units. You can see their table, just you can see volume, length and cube, meter cube, density, mass per unit volume, kilogram, meter cube, velocity, distance covered in unit time, meter per second, acceleration, velocity change per unit time, meter per second square, force, mass into acceleration, kilogram, meter per second square, work, force into distance travel, kilogram meter square per second square, and pressure, force per unit area, that is kilogram per meter per second square. So we have seen some various objects as large as the mountain to as small as a speck. Therefore, to measure such large and small quantities, we have to use a simple method. Just he had given this example, just you can see. Diameter of the sun they had given you in meter, and diameter of the hydrogen atom also they had given. Thus, when we are using meter, we find that the concept is either quite bulky or very small. At the same time, it is very inconvenient. Okay, the diameter of the sun will be 1.39 to 10 to the power 9 meter, and diameter of the hydrogen atom will be 1.06 into 10 raised to minus 10 meter per meter, you can say, the exponential part. Okay, now we'll discuss it in another video. Okay.